Hello everyone. Welcome to the second video of Azure AI Fundamentals Certification course. In the previous video, we discussed about Azure AI Vision, and this one we'll be discussing about Custom Vision. The concept of this lesson is inspired from the AI-102 certification training I attended to pass the certification. I'll provide the link to this training in the description box below. Now, without further ado, let's get into the video. Custom Vision is an Azure AI service used for classifying images and detecting objects present in the image. The only difference of Custom Vision from computer vision is that here you have to train the model with your own data. That's why the name custom. The models are custom to your use case. So you have to bring your own data. In this case, the data is labeled images. So you need a set of labeled images. You have to train the model, test the model, and once the testing is successful, you have to deploy the model. So that is what is custom vision. Now, custom vision contains two features. One is image classification and other is object detection. Now, what is image classification? So it is classifying the image to categorize the image, this or that. That is what is image classification. Now, object detection is detecting all the objects present in the image based on the training data. Now, let us see the documentation. So, custom vision, as we discussed, will let you to build, deploy, and improve your own image identifier models. You can apply labels to the image and then train the model and you can deploy them. That is what is custom vision. To develop a custom model for your own use case or for your own business needs. Now, as we said, custom vision functionality can be divided into two features. One is image classification and the other is object detection. Now, it is very important to know the difference between image classification and object detection. There will be questions where you have to select the proper feature. So now what is image classification? It will apply one or more labels to an entire image. So it is categorizing or classifying an entire image to one group. That is what is image classification. Now what is object detection? Object detection is similar, but it returns the coordinates in the image where the applied labels are found. So there is no categorizing the image into any particular group. It will just detect the object and returns the coordinate where that particular object is present in the given image. That is object detection. Now let us go to the Azure portal and create a custom vision resource. So here in Azure AI services, you can see custom vision. So we'll create a custom vision resource. So now while creating, it will ask prediction or training endpoint. So what is this? So training endpoint is used to train the model, to train and test the model. And once the training and testing is successful, we'll deploy the model. Then we'll get a prediction endpoint. That is an endpoint which is used by our users. So this is the deployed endpoint, which is prediction, and that is training, which is used to train the model. Now what we need is both. Now we have selected the subscription and I don't have any existing resource group. So I'll create one, the default region, and I'll provide a random name. Now I'll select the free tier and everything. I will leave default and will create the resource. So it will take few seconds to deploy it. Now, once the deployment is successful, we can go to the custom vision resource. Then we'll be doing our demo in the custom vision portal. So here you can click the custom vision portal. Again, here in the portal, you can see the endpoint URL and also keys. So this keys and endpoint are needed if you're connecting to this custom vision API programmatically. So that is what the purpose of key and endpoint is. But here in our demo, we'll be using custom vision portal. Now first I have to create a new project in custom vision studio. So I'll create a project. So first we'll be doing the demo for image classification. So I'll give classification project 1, give a description. Then the resource is our custom vision resource which we created just now. Now again, you have to choose the project type. So there are two project types. One is classification and other is object detection. So here we are going to select classification because that is the demo which we are going to do. Again, there is classification types. So for classification types, there are two options. One is multi-label and one is multi-class. So what is multi-label? So in multi-label, there will be multiple tags per image. And in multi-class, there will be only one tag per image. So here we are going with multi-class, in which there will be only one tag for the image. Now these are the domains available. There is general, food, landmark, retail, and certain compact domains. Now we have to select the domains based on our requirement. So for example, generic domain is for a broad range of image classification. You can choose this domain. Then food domain for the photographs of dishes, fruits and vegetable. We have to choose food domain. Then anything related to landmark, we can choose that domain. Then there is a retail domain for shopping catalog or shopping website. If you want high precision classifying between dresses, pants, shirts, etc., we can use the retail domain. Then the other is compact domain. So compact domain is used when the model has to be exported to run locally, or when the model is supposed to run on an edge device or on a device where there is intermittent internet connectivity. If that is the case, we have to select the compact domain. Again, we can export a model from one domain to another domain. So we have an already existing model in the food domain, and later we got a requirement to run the model on an edge device. So we can export the model to any of the compact domain, retrain the model and redeploy the model. So that is what is compact domain is. Now let us get back to the Custom Vision Studio. So here we can select the general domain, go with the default domain, and then we will create our project. So now our project is created. So we can train our Custom Vision classification model. So we'll go with quick training. So first we have to upload our images. So we'll add image. So in my case, I have downloaded the image from this Microsoft GitHub repository. So this repository has various images for classification as well as object detection. So you can clone the repository to your local machine. I'll provide the link of this GitHub repository in the description box. So for classification project, we are using flower classification, and here we have images of daisy, iris, tiger lily, etc. We'll use daisy and iris for training. So we have so many images. All these images are downloaded from Azure repository. Then here there are iris image. We'll be using only 10 images of each to train our model. So I'll select 10 images and then open it. Then I have to provide a tag. So I'll provide the tag daisy. Now our project is multi-class, so we have to provide only one tag. Now I will upload the files. Now 10 images are uploaded successfully. Now I will upload my next set of images, which is that of iris. So I'll use 10 images. If you want your model to be more accurate, you can use as much image as you want. Now I'm just going with 10 images, and I'll tag these images as iris and will upload this. Now these are all the images which we have uploaded. Now there are no untagged images. We have tagged all the images. Now next step is to train our model with the uploaded data. So I'll click train button. Now I'll go with quick training. Now this will take some time. So I'll pause the video and come back after the training is done. So now the training is complete. It took approximately like 10 minutes. Now here you can see the evaluation metrics of the model. And here it says everything is 100%. So our model is a small one and we haven't trained it with so much amount of data. Now we have provided iris and it has precision of 100%. And okay, I have provided the name of daisy wrong, but that's fine. And here also the precision and recall and average precision is 100%. We'll come to this evaluation metrics later, but before that we can test our model. So we'll go with quick test and I'll provide a local file. So yes, first we can provide the image of an iris. So the first 10 image we used to train, we can select some other random image for testing, which the model has not seen before. So let us see whether the trained model is able to identify or classify the new image. Now it is processing and yes, it is able to categorize it properly. So it says iris with 99.6% confidence, which means the model is pretty sure that the provided image is that of iris. Now we can give another image. So now we can provide the image of Daisy. So I'll provide this image. Now let us see. Yep, the model has identified it as a Daisy with 99.9% of confidence. So that is pretty good. Now we can select a random image, an image of that of tiger lily. So this is tiger lily flower and I'll use this image. And let's see what the model is going to say. So the model is not trained with this image. Okay, so the model is not sure here. It is saying the given image is that of iris 84.9% and that of Daisy 15%. Again, we can't blame the model because we haven't trained the model with this particular image. So that is how an image classification model works. So this is the first iteration or the first training. So if the precision and recall rate is very low, you can again upload images, label those images and retrain the model. So that will be iteration 2. Then you can train and retrain the model until you get a perfect or near perfect evaluation metrics. That is the idea. Now I'll explain the evaluation metrics after the object detection demo. Now if you want, you can deploy this model and use the prediction endpoint for classifying the images. But we are not going to deploy this model as of now. Now let us see an object detection project. Now I'll create a new project. I'll name it object detection test 1. So this is the resource which we created in the Azure portal. Now the project type is object detection. Again, we'll go with the general domain. So once we selected object detection, the multi-class and multi-label has gone and the domain also have changed. Now the domains present are general, logo, products on shelf. So in the case of a retail store or a supermarket, it can detect different objects or items present on the shelf. Then there are compact domains. Now I'll go with general and will create the project. Now again, I will add image, and in this case, the image I'm using is grocery checkout in this folder, and this is from Azure GitHub repository, and I will use this images. So there are images of tomato, cucumber and red chili here. So first I'll use tomato, 10 images, upload these images. Now the images uploaded. Again, I want to tell about smart labeler feature. So again, as the name, it is a smart labeler. It will provide suggested tags for the object present in the uploaded image. So you can verify those tags and check whether it is correct and apply those tags to the object. That is what a smart labeler is. Now what we have to do here is, I have selected the particular object and I have to add the tag. So here in object detection, you have to note that we are not tagging the entire image like previously we did for image classification. We are just selecting that particular object, the bounding box around that particular object, and we are tagging it. So I'll tag it as tomato. Now one image is tagged. Then I have to tag all the remaining 9 images. So I'll tag these images and will continue with the recording. Now in the case of this image, there are 2 tomatoes present. So I will label them separately and save it. Now these are the tagged images. Now I have tagged all the 10 images. So all of them are tagged. Now I will add the next set of images. For the time being, I'll use tomato and cucumber images. So I'll use 10 images of cucumber to train the model, upload the 10 files. Now the images are uploaded and now I'll continue tagging these images. So here the tag is cucumber. I'll tag them separately because those are 2 objects present in the same image. By the way, you can drag and create a rectangle box around each object and then tag it. Now I'll tag every image and then come back. Now I have tagged all the images. Now let us train the model. We'll go with quick training. So it's saying you need at least 15 images for every tag. So I will upload more images and then train the model. Now I have uploaded 15 images each. Now we can train the model. We'll go with quick training. Now, after a few minutes, the training is done. Now the precision is 100%, recall is 75, and mean average precision is 90.3. These are the tags we applied. And for Cucumber, the recall rate is only 60%. So to get more recall rate, we can upload more images, tag it and retrain the model. But for the time being, we are going with this one. We'll do a quick test of the model. Now for testing the model, we'll upload an image. I'll select this one. Okay, now it has tagged these objects in the image. Now there are multiple tomatoes in the image and it is able to identify all of them. That's good. And it has identified the cucumber as well. And here you can see the confidence score. So if you hover around each of them, you can see this is identified as tomato with very high confidence score. This one as well. This. Now cucumber, the confidence score is less. It is 27% only. And for cucumber, the bounding box is not that correct. So if you want, we can train our model again with more images. Now this it has correctly identified as tomato with very high confidence score. Now that is what is object detection is. It will detect multiple objects present in a single image and provide the bounding box where each of these objects are present. Now we have used only two types of object. You can train with multiple objects. You can use the chili. You can use other vegetables and give an image with multiple different vegetables and it will be able to identify all of them. So this is what is object detection is, identifying multiple objects present in a single image. So now we can summarize what we have seen. So image classification, it is a feature of custom vision where we train our model and customize for our own needs. In image classification, we'll categorize image into predefined labels. We categorize into groups. It can classify images based on their content and we can apply one or more labels to an entire image. We have seen multi-label and multi-class. Now what are the use case scenarios? So in the question, they will give a scenario and will ask you which feature to select, whether it is image classification or object detection. So some of the use cases are, we can classify products based on categories like electronics, clothing, groceries, tomatoes or cucumber. So classify the products. Classify images from X-rays, MRIs or other scan to identify conditions such as tumors, fractures or other diseases. So if we train the model with unhealthy X-rays and healthy ones, so it will be later on able to classify them. So if an X-ray contains a fracture, it will be classified under the fracture category. And if it is a completely perfect X-ray, it will be classified as normal. So for detecting diseases, fractures, etc., image classification can be used. We have seen the demo of image classification. Next is object detection. So it is to identify and locate multiple objects within an image. So in image classification, we are assigning a category to an entire image. But in object detection, it will detect objects, label them and provides their coordinates or bounding boxes. Now what are the use cases? Identifying defects or missing components in production. So your company is producing a particular engine or a hardware part, and if any defect is present in that product, maybe one part is missing or in some area there will be a dent present. So object detection will be able to pinpoint that area and provide bounding box and give the coordinates and tell you, hey, there is a defect in this particular region of this product. So that is identifying defects in production. Then identifying suspicious items or intruders in real time. Monitoring crop health by detecting diseased plants or weeds. So if there is any insects present on a plant, it can pinpoint that area. Or if there is any rot present in the plant, it can be detected. Then again, if you're packing a box, the box should contain 5 items. And if 5 items are not present, it can be detected. Then automatic checkout by detecting products in shopping carts. So it can detect all the objects present in the shopping cart if the model is properly trained. then defects in factory produced items. So these are the use case scenario of object detection. Now, one final thing I have to touch up is the evaluation metrics of these custom vision models, which is precision, recall, and mean average precision. So here we have seen the evaluation metrics. And if the evaluation matrix is satisfying only, we have to deploy our model. And this can be seen both in our classification project as well as in our object detection project. Now, what is precision? This number will tell you if a tag is predicted by your model, how likely is that to be right. Now, recall. This number will tell you out of the tags which should be predicted correctly, what percentage did your model correctly find. Now, mean average precision will tell you the overall object detector performance across all the tags. Now, what does this mean? Let us clarify it. Now, what is precision? Precision tells you how accurate your predictions are, or how accurate the predictions of your custom vision model is. So first, let us have a look at the example. Now, there are 100 images and your model predicted 100 images as dog. And after that, you are verifying these images and you found out that 99 of these 100 images were actually dogs. But one image is not that of dog. It was that of a cat. But the model classified it into the dogs category. So 99 was correct, but one was misclassified. So in this, 99 is called the true positive, where the model was truly able to identify the correct category or the correct object in the case of object detection. Now, precision is true positive divided by true positive, which is again 99 plus false positive. Now, what is false positive? Here, one is false positive, which the model categorized as positive. That means the model said that image is that of a dog, but that was a false positive, which is a wrong detection or wrong classification. So that is false positive. Now, precision is calculated with true positive divided by true positive plus false positive. And in this scenario, it is 99 divided by 100, which is 99%, which means that 99% of the time when the model predicted dog, it is correct. It is actually dog. But in 1% of time when the model predicted dog, it was not actually dog. It was some other random image. That is what is precision. Now, next metric is recall. Recall is how many actual items were correctly identified. Now, straight to the example. Now, there are 100 images of dogs in the data set. So, in the data set, here it is a data set. And we have 100 images of dog. Now, these images were given to our model and the model said 80 of them is dog, but it was not able to identify rest of the 20. Either it misclassified or it was not able to identify those images as that of dog. So 20 are misses, 80 are identified correctly. So that is what is recall rate is. Just true positive, here 80 was actually that of dog, and true positive again 80 plus false negative. These 20, the model said those are negative for dogs, but actually those were indeed dogs. But the model gave it as false negative. That negative was false. So this 20 is false negative. So recall rate is true positive by true positive plus false negative, which is 80 divided by 100, 80%, which means that the model identified 80% of the actual dogs correct. That is what is recall rate is. So precision means how many of the identified classifications were actually correct. And recall measures how many of the actual items were correctly identified. So now these are the evaluation metrics of a custom vision model. Based on these evaluation metrics, we have to decide whether we have to retrain the model or deploy the model. In this lesson, we discussed about custom vision, its features that are image classification and object detection. We also did demo in the custom vision portal. We also discussed about the difference between image classification and object detection. Now in the next video, we'll be discussing about Azure AI Language Service. Thanks for watching the video, and I'll meet you in the next.